so I'll get out of the way now. Our first team today is Holly and Mako, and they're going to be talking to us about UI and UX. So let's give it up for Mako and Holly. Yay!
Thank you so much, Heather. We're really excited to be here today. And our talk is going to be comparing UI and UX practices in Japan and the US. My name is Hallie, and I'm here with Mako, and we're really excited to talk about this. So, our first slide, Mako's going to talk about UI.
Yes, I will talk about what is UI first. The user interface is a graphical layout of an application. It consists of buttons users click on, and text they read, the images, text entry fields, and all the rest of the images in the user interacts with. This includes screen layout, transitions, interface animations, and every single micro interaction. User interface design focuses on expecting what users might need to do and ensuring that the interface has elements that are easy to access and understand. So, what makes good user interface? Let's see best 6 practices for designing interface. First, keep the interface simple. The best interfaces avoid unnecessary elements and are clear in the language they use on labels and in messaging. In this example, it has many contents in different sizes and shapes. But in the good example, contents are in similar size and pattern. Second, create consistency and use common UI elements. By using common elements in UI, users are able to get things done more quickly. It's also important to create patterns in language, layout, and design throughout the site to help improve efficiency. In the good example, it applies consistent page design, and it's easy to understand how to use. Be purposeful on page layout. Consider the structural relationships between items on the page. Careful placement of items can help draw attention to the most important pieces of information and can aid scanning and readability. As you can see, in good form, user can go through down and it's easier to use. Next is strategically use color and texture. You can direct attention toward or redirect attention away from items using color, light, contrast, and texture. This is image good example for contrast. Next is use typography to create clarity. Carefully consider how you use typeface, different size, fonts, and arrangement of the text to help increase readability. As you can see, good spacing aids readability. Make sure that the system communicates what's happening. Always inform your users of location, actions, changes in state or error. In the left side image, a good example, error message is displayed below text field so that user will find error message and resolve it. Okay, let's move on to the next section.
Thank you so much, Mako. And now I'm going to talk about the second half, which is what is UX? And UX stands for user experience. So user experience takes in all of those UI elements that Mako talked about, and it considers all of them and makes sure that they have great design. The next element of user experience is that the product is intuitive to the user. We want to make sure this product is easy to use and it's really obvious how you are supposed to use the product. The next element is that user experience takes into account the user's overall impression. You have a goal with user experience that you want your user to take away something, and we want them to have a great overall impression, and we want that to be a really strong feeling. And finally, as I keep saying, it looks at the entire package. So it takes into account UI and takes it to a whole other level, kind of like a broader view, and makes sure that the whole package is amazing. So an example of UX. You may be thinking, this is a tech talk, why are you not using a technical example? Well, I would like to use the Disney theme parks as a great example of user experience because they have been doing a great job at this since the 1960s all over the world. And they've done that through design, intuition, and the overall impression that they leave their users with. So with design, Disney theme parks, they have recognizable fonts. If you have ever seen a Disney VHS or a DVD or any sort of TV show or film from Disney, they always have this title card with that curly Walt Disney font. That's very typical of Disney. At their resorts, they have this Disneyland kind of old-timey, fantasy-esque font that they use, and that's also very recognizably Disney. They want their users to know, this is a Disney product, and they do that with the fonts that they choose. The next thing, they use colors to their advantage. So when you're at a Disney theme park, you will recognize color groupings and know that you're in certain sections of the park or it's a certain character's ride that you're about to go on. So I have a really fun example activity, and it's going to really, I think it'll really show you how well Disney uses color to their advantage. So let's look at this image. These are Disney princesses. You may be thinking there are no faces or clothes, but I assure you they are Disney princesses. So why don't you take a few seconds to look at these blocks of color and guess how many Disney princesses you can actually name. Okay, now the text is at the bottom of the images here. How many of them were you able to name? I was surprised myself when I first saw this image that I think I guessed all of them correctly, which I am a Disney fan, so that proves my point that I am a Disney fan, thank goodness. But it was really interesting to me that just by having these blocks of color put together in an organized manner, that I was able to recognize, oh, that's Snow White, or that's Mulan. It was really interesting to see that possible, and that's because Disney is really good with their color usage. And our next example, Disney theme parks, they are intuitive to the user. So they have audio cues in the different sections of the park. If you are at the beginning of the park on Main Street, you're going to be hearing a lot of jazz music and big band music. So you know just by closing your eyes and listening, that's where you are. Now, for visual cues, at the center of every Disney park, there is a really big fairy tale princess castle, which we can see in the image here. And that is going to help users look to the center of the park at that castle in the middle and figure out where they are. So it makes navigating the park intuitive. If you have ever visited Tokyo Disney Sea, you know they do not have a Disney Princess Castle, but they have a massive, massive volcano that spews fire and smoke every so often. And so that's the visual cue at Tokyo Disney Sea that helps users get around the park easily and figure out where they are. And finally, Disney theme parks leave a really great impression with their users. They keep this user experience in mind overall, and they want to make sure that their commitment to customer service is top-notch. So they have lots of staff on hand that are going to be helping their users and making it really easy for their users to interact with the park. And they provide a total immersion for their users. So that even goes down to like the people who are picking up trash. They are not just, in maybe like a worker's uniform, let's say. They're actually wearing clothing that matches the theme of the section that they're working in. And so Disney is like at these small details. Even at those small details, they are providing an immersive experience because they want their users to have a great, great impression of their theme park. And that's how Disney has done an amazing job with user experience. And our next section, Mako is going to talk about a story.
Okay, we shared what is UI and UX. Let's review it in this section. I'm going to tell a story. That is a man who wants to use a vending machine. Think about which part is UI and which part is UX. I will talk to you about data. It's a hot day. I want to drink something cold. Oh, there is a vending machine. I'm going to buy cold water. How can I use this vending machine? Finally, he was able to buy water, but it was not cold enough. In this story, the man was confused about how to use the vending machine. When the drink finally dispensed, it was not cold enough. He decided never to use it again. Let's separate them into UI and UX. This is very implemented UI. This part left the man with a bad impression of a vending machine, and it is UI. Let's move on to the next section.
Thank you, Mako. So now that we've introduced you to the concepts of what UI and UX are, let's look at the history of those in practice in both Japan and the USA. So we have our map here. The US is the red circle on the left there, and Japan is the yellow circle on the right. Just for some geographical context, in case you don't know where the two countries are. And now Mako's going to talk about the history in Japan.
Thank you, Harry. I will talk about history UI UX in Japan. Japan is a mobile first country. Flip phones are widely used from 2000 to 2010 in Japan. Japan was early adopter of mobile web navigation, and while the world was displaying websites through their tube screens, the Japanese are using their flip phones to access information through 3G in tiny screens. So they needed to fit a lot of information in a small space. Those images are websites for flip phones. To make it easy to read and load, these early websites are purely text and contain lots of information in a minimal space. Those are current features of Japanese websites. They have lots of information, crowded and busy, colorful, and have kawaii characters on many websites. Let's move on to the detail. First, Japanese websites use lots of text. Expansive use of text is due to the nature of language itself. Japanese characters can contain a lot of meaning in just few characters. It allows Japanese speakers to be able to process a lot of information in a short period of time. One more reason for heavy use of text is need to convince buyers. Japanese consumers require lots of detail and convincing before they buy items. This led to Japanese website use of heavy amounts of text. We will compare Japanese and American websites later. Next, crowded, busy, and colorful. This is a typical Japanese flyer, and it is important form for advertisement in daily life. Japanese people use this flyer to find the best offers for everyday products, and they are used to quickly scan and clearly evaluate the information. Speaking of color, certain colors have different meanings in different cultures. For instance, in Western cultures, red is the color of love and excitement and can be associated with both negative and positive purposes. But in Japan, it means happiness and joy. Final feature is kawaii character. Kawaii character is usually found on websites, homepages, or as part of advertisement. This is website of Hikone City in Shiga Prefecture. They use their own character called Hikonya on their websites. Let's move to the next section.
Thank you, Mako. And now I'll take a look at the history of UI and UX in the USA. So we have an image here, which is an image of the original Macintosh home computer. It was released in 1984, and to our modern day eyes, this computer looks, well, frankly, pretty basic, but at the time, it was revolutionary because it came with a graphical user interface, it had a built-in screen, it came with a keyboard, and most revolutionarily, it came with a mouse. So you can now click on your screen instead of having to type keyboard commands to navigate your computer. So at the time, that was pretty amazing, and it made it possible for computers to come into people's everyday lives and they could use them at home. Now, in more modern times, Apple again revolutionized the mobile UI UX scene when they introduced the iPhone in 2007. And the iPhone was revolutionary because it did away with the physical keyboard. So I'm sure many of us remember sending text messages on our flip phones, and you had to like furiously punch through the keys to get to that letter you were trying to use to write your message. But the iPhone did away with that. It now had a touch screen, a QWERTY keyboard built into that touch screen, and it really made the screen even bigger. So now you could access more websites a lot easier via your really big screen. Another thing is, even more recently, voice commands. So that's another element of UI that's been added recently. So we see the iPhone again, which has Siri built into it, the Google Home Assistant, and Amazon's Alexa device. And this is a pretty interesting invention more recently because people can now just talk to their phones. I know I do myself. When I need to set a timer or an alarm, I just talk to my phone and have it do that for me, which is really convenient. So overall, UI and UX in the USA is characterized by these four things. Number one, they use less text on their screens. That's coming over because many people use computers, and that's where users were coming from originally. So you have a mouse, it's really easy to just click around. You don't need all of that information densely packed onto your small screen device or device screen. Number two, because you have a bigger screen that people are using, you can have really, really big images. So there's a much bigger emphasis on large images and less text. Number three, because of these things I just talked about, people are clicking through more in order to get the information that they need. And we'll see that later when we are comparing our Japanese and US websites to each other. And finally, because US users are coming from many different types of devices, whether that is a home computer, a laptop, a tablet, or even a mobile device, developers in the US have had to make their websites responsive because they can't really predict where their users are going to be coming from and interacting with their app or their website. So that's why they've really made their websites a lot more responsive. And now we will go into our comparison section, as I just said. So our first example, we are going to look at two websites, supermarket websites from Japan and the US. Okay, our first example. A Japanese supermarket website. We have Aeon Supermarket here, and I took this screenshot a couple weeks ago of their homepage. We can see that there's, wow, a lot of really bright colors on the screen. And as Mako just explained, that's really typical of Japanese UI and UX. We also see a lot of information, like, oh my gosh, there's information about a credit card that's on offer, even more deals down here at the bottom. And off to the side, we see this really cute image with some children jumping and a really cute, I think that's an owl, but I'm not totally sure. I'm just gonna go with owl, but it's a cute character, right? So this is very typical of Japanese UI and UX. Now, if we look at the American website, we have Fry's Food Stores here, and their homepage is quite different. It's very few colors, mostly blue, mostly white. We have a massive, massive image in the middle, a little bit of text, but they're just expecting the user to go to the top at that search bar and look for the item that they want, or to click in this right-hand corner, for their cards, to sign in, find a location. They expect their users to have an idea in mind and navigate themselves by clicking through. So if we look at these websites side by side, yeah, we can see that there are some similarities with the login feature and some categories in the navigation bar at the top, but overall the websites are very clearly Japanese UI and UX and USA UI and UX. So we're going to take a look at a couple more examples, and Mako will talk about our next one.
Next example is aquarium websites. This is a website of Kamogashi World. On the top of page, it has navigation bar. On the middle of the page, you can find information on staying plan, office hour, admission fee, and access information. We can get many information by just visiting top page. Next is website of Monterey Bay Aquarium. It has big image and less text. Clicking button on navigation bar will navigate users to the page which has detailed information. Let's see the pages side by side. The differences are obvious. In Japanese website, user can get basic information by scrolling the top page. On the other hand, in website from the US, user will click button on the top page to access information they want. We will move to the next example.
And our final example, we're going to compare online shopping retailers. So, the Japanese example, Rakuten Marketplace, the perfect example to use here in Japan. And we can see this homepage right here that has lots and lots of bright colors again, and some deals down at the bottom here explaining, some discounts you can get, other things that are on sale. We have a really some wonderful imagery in the middle with a man reading a book next to his cute cat, and a woman who's enjoying a really nice cup of tea. And this website is, it looks really Japanese, like I said, with the bright colors and all the information on the page. If we go to the US online shopping retailer, Amazon, this is their homepage from a few weeks ago. We can see that the colors there's actually a decent amount of colors that are being used on this website, but they're much more dull. They are less bright. And there's less information about what deals are happening. And mostly the focus again is at the top for the user to search for the product they want, to click something on that navigation bar, sign in, check their cart, things like that. If we look at the websites side by side, I actually have to say that the websites are organized pretty similarly in the sense that there's that massive toolbar at the top, and that there's the information about logging in, what's in your shopping cart, your favorited items, and things like that. But as you look further down the page, that's where they differ. The Japanese site has tons of information that they're giving to you immediately. Whereas the US website doesn't do that. You're gonna have to click through and look around the website to get that information that you might want. So Mako's gonna talk about some final thoughts.
Yes. In concluding our tech talk, websites from Japan and the US have the following differences: color usage, graphic size of graphics, page layout, and amount of information in one page. If culture is different, there is own characteristics of websites. Just translating content and using the same interface design might not work well. There is no right or wrong way to do UI UX as long as you have the user's needs in mind.
So thank you so much for listening to our talk today. We were really excited to put this together, and we learned a lot about our two cultures and how they design websites. So if you want to get in touch with Mako, you can scan her QR code and find her on LinkedIn. And if you would like to get in touch with me, Hallie, I can also be found on LinkedIn, and sometimes I'm tweeting on Twitter. Thank you so much.
Okay, thank you so much, Mako and Hallie. That was great. At Code Chrysalis, we watch these rehearsals happen before we do Big MiniConf, and I remember the first time I saw this, I learned so much and finally understood so many things about the country that I've lived in for the past 7 years. So it was a really impactful talk for me, and I really, really enjoyed it, and I hope that everyone here did too. So I'm going to welcome the next pair up to the stage, so please come up, Polly and Yuya. They're going to be, sorry, not Polly and Yuya. I'm sorry. I'm all mixed up. Okay, so actually next is going to be Chip and Izon, and they're going to be talking to us about machine learning and taking us through a tour of some wonderful, wonderful paintings as well. So really excited about that. All ready? Think so?
I'm sure so.
Yes. Go.
thank you for listening to us today. My name is Chip Crawford, and I will be talking about machine learning with Izon. We explored machine learning through painting, right? Our goal was to see if two novices could train a machine learning algorithm to classify paintings. Okay? And we did this through Google's Teachable machine. We created a algorithm to classify paintings based on country and time period from 1400 to 1900. We did some research into Google's Teachable machine and how it relates to transfer learning. And we'll be able to share our results and give a brief demonstration of how to use Google's Teachable machine. And finally, we look into why our model performs the way it does, its strengths and its shortcomings. So to start off with, I'll hand it over to Izon, who will talk about machine learning in general.
Thank you, Chip. So what is and isn't machine learning? So let's say you want to determine a face recognition model. So how we would do that? Maybe we would ask a person to classify them for us, to label them for us, but it is very time and money consuming. Also, human can actually write a model, classifier says this is this emoji, this is this emoji, but human actually can take this much information only. So instead of that, machines make that for us. So how can we do that? This actually would save us a lot of money and time. Okay. So how can we do that? Let's say for the simplicity, we take these animal emojis, and we first need to show machines the data we want it to classify. So we feed them these animal emojis with its labels. Say this is a cow, this is a fox, this is the lion, and machine will learn from the data using those labels and actually find the patterns inside the data. And this stage is called training stage. And actually it could create us this animal classification model. So with this trained model, we can then actually classify this new data, new emojis we want them to classify and use this. So this is called testing stage. So this we give a model the new information and it can classify for us. So very fast. And before diving into deeper, let's sort out some buzzwords like artificial intelligence, big data, machine learning, data mining, because it sounds very confusing and scary for many of us. So artificial intelligence, it's a very broad field that aims computers, machines to emulate human patterns, human performance. Big data refers to storage and computing really fast the large amount of data. And machine learning is a subfield of artificial intelligence, and it becomes possible when AI needs big data. So its aim is to give the machines access to the data and let itself to learn from that data new patterns by developing algorithms and yes. And data mining is a little bit different. And data mining use techniques to extract from data new patterns that human may not know. So let's see what's the difference between machine learning and data mining. Okay, can a machine learning algorithm tell you something new? The answer is no. For example, machine learning only can do tasks what we set it to do and learn from the data what we feed it. So in this case, it can determine between lines, boxes, and curves because we said this is and this. But data mining can find new patterns from data itself without any instructions. So as you can see here, we gave it data and it could find new emojis, new types of emojis we didn't even anticipate it to find. So this was a brief introduction to machine learning, and Chip will introduce you the concepts we used in our experiments. Chip.
Thank you, Aizan. So yes, I'll be talking a little bit about Google's Teachable Machine and transfer learning in general. Okay, so let's take an example of a model which can classify animals as cats, dogs, or raccoons. Okay, so the original model has 3 categories. Right? And if you present a picture to this model, it will rate the similarity between the 3 models it already has, or the 3 categories it already has. In this case, we have a pug, and that looks very much like a dog, maybe a little bit like a cat or a raccoon, but this model would confidently predict that this is a dog. Now, if you present it with something that falls outside of those 3 categories, right, in this case, a tanuki, the model isn't going to perform well. It hasn't been trained to do that, right? So it'll say this creature looks a bit like a dog and a bit like a cat and a bit like a raccoon. And it'll say it's a dog because that's the strongest measure it has, but it won't be very confident, and we know that this isn't an accurate assessment. Okay? So how do we use transfer learning to make a better model, make a model that can handle our new category? Okay, well, we take our original model and we add in our knowledge about what is a dog, what is a cat, what's a raccoon, what's a tanuki, right? And we use that, we use the transfer learning algorithm to bring that all together to produce a fingerprint, right, that says a tanuki looks like something that is 40% dog, 20% cat, 40% raccoon, or some such ratio. And now, right, our model is ready for these new images, okay? We now have 4 categories, right? And when we introduce our original image, the model will say, it looks a little bit like the first 3, but it really looks like a combination of all 3 of those. And so then the model will confidently say, this is a tanuki, this is your new category. Okay? But what about if we bring in another one, right? How is that going to work? And I want to change our focus a little bit, right? The more ways you approach a problem, the easier it can be to understand. Let's imagine we now have a case where we have two categories in our model, just dog and raccoon, right? So when we bring in a dog, an image of a dog, we now can break it up into a 2-dimensional space, right? And in that space, you'll have raccooniness and doggiosity. And when you have an image of a dog, it will fall strongly towards one axis as opposed to the other, okay? And again, when you bring in a raccoon, it'll fall strongly towards one axis and not the other, okay? And so this is a way of thinking about how this measure works. Now, if we bring in a picture of a tanuki, we can see it falls somewhere in the middle between those 2, okay? So let's go back and try to do the same thing where we train the algorithm to bring in this case, a 3rd category, okay? So we bring in a bunch of images of tanukis, and we plot all of those in our new 2-dimensional space, and we see that there's a certain region that can be defined, and that region will include all of these images. So now that we have this new region, we can bring in our original image and see that it falls somewhere in the middle of that region. And so now we have the same 2-dimensional space. We haven't added any dimensionality, any new information. We've just divvied up that space in a different way. And now if we want to bring in a civet, in this case, and add another region, we can do that by taking our space and defining a fourth region. And you can imagine chopping up this space, into finer bits to include different sorts of creatures. Okay. So I will hand it over to Aizan to talk about our experiment. We'll move away from animals and towards paintings.
Thank you, Chip. I will first explain the overall architecture. So we first take original machine learning which was trained on the big data, and this one actually comes from the Google's Teachable machine. Then we get our paintings, then do the transfer run and then get the period arc paintings classification model. So where we get those paintings is from here. This is the open source web gallery of art. You can also check it out by this QR code and actually see the paintings. So, and lots of other things. Okay, so after we brought the paintings, we need to reprocess them. So to do that, from the older data, we divide it by 50-year span and country, and by total we get 36 categories in total. So then we should divide it into training and testing data. So for training, we should actually say this is from this year and from this country to the model to show it, and then actually test it if it could classify it correctly. So training goes like this. For example, in this first row, we can input training data with its labels. Here, this one is from Flemish 1400 and 1415. It has this images and so on. All our 36 categories. And training goes like this. We fine-tune these hyperparameters to actually the model to fit this data we fit it. As a result, we get the model, so we can actually test it, how it works. So we feed it very new data, which it didn't see in the training. So we know that this painting is from 450 and 1500, it's Flemish one, and model actually could model actually predicts the output of the model correctly with 61% of confidence. Yay! So yes, Chip will demonstrate it to you how it works.
Thank you, Aizan. Yes, like Aizan said, I'll do a brief demonstration, and afterwards there'll be a QR code. If you guys want to play with our model and try to break it, please do, let us know how it goes. Here we have the interface for the model, and we have a selection of pictures we'll use for our demonstration. The first is the portrait of the marriage of Arnolfini by Van Eyck, a very famous early modern painting. I would like to point out a very impressive mirror in the background. Well-known painting, and if we bring it over and we can drop it into the classifier, we can see that it can accurately predict that it is Flemish, and it's very sure that it is from 1400 to 1450. Great, so a success for our model. Let's move over to this next portrait of the Duke of Savoy by Quentin Matisse, I believe you pronounce it. I just liked him. Something about him struck me. And so again, we can bring it over, and a very accurate determination by the algorithm, right? This is Flemish. This is the right time period, the second half of the 15th century. And it's pretty sure it's Flemish. It gives a slight nod to Italian, but the strong feeling is Flemish. So the next one we'll look at is from an artist that's a personal favorite of mine. This is Bernini, mainly known as a sculptor and an architect. Amazing work as an architect. But he also did painting, Renaissance man, as they say. And so if we pop this one in here, now we've got to go down a little later, and it says, okay, maybe Italian, this period, and it says 1650 to 1700 Italian. This is our first failing of the day. This is actually 1600 to 1650. It's a little earlier, but he was prolific throughout the 17th century, right? So he was working in both halves. So maybe we can have a little sympathy for the machine for not nailing this one, because he did span that period. And then finally, let's jump ahead a couple centuries. This is an American piece by Pendergrast, a Bostonian painter, and it's a painting of Venice. Okay? And I was actually pretty impressed that it got this one right, as we will see. It classifies it as an American painting, and I was impressed by this because it does strike me as being very impressionistic and of a piece with a lot of international art at that time. So overall, you know, we looked at some very successful and one kind of not so successful classification, but how can we understand why our algorithm fails sometimes, right? Why isn't it perfect? We hear so much about what machine learning can do and how strong it is. Well, our categories aren't perfect. Right? If you look at the image here, we can see how borders have formed and shattered and reformed across Europe over the time period we're talking about. So we look at a map of Europe today, and we think of it as, oh, that's Europe. Germany's here, France is here, Poland's here. But that's not always the case. You know, borders move, peoples move, and people talk. So a painter that is classified as Flemish, right, might be talking to Italian or French painters. And also not just in space, if we think about time, right, we, when doing our project, had very rigid time periods, right? 1650 to 1700, 1700 to 1750. But a painting done in 1699 would probably have a lot more in common with one done in 1705 than with a painting done in 1651, right? So we draw these sharp categories, but they're not reflecting the actual continuous flow of, well, life, reality. So the machine learning algorithm can only do as good and an accurate a job as the information we give it, right? We give it, you know, hard categories, it'll make hard choices that aren't always perfect. So for the conclusion, I will hand it over to Aizo.
Thank you, Chip, for beautiful demonstration. So from conclusion, we can say that we could successfully train an image classifier model using teachable machine. So our main goal here is to show you that machine learning is becoming more accessible and more fun to use for more people. So please try it out, try to use it, and it's really fun to use. So you can also check our model here. Play with it, maybe break it. Yes. So thank you. We had enormous fun doing this project. And you have any questions, you can contact us by these QR codes. Thank you very much.
Thank you.
Okay, thank you very much, Aizan and Chip. I think one of my favorite things about Big MiniConf and about working at Chrysalis in general is getting to see how people's backgrounds and individual interests actually play out in the stuff that they choose to build and the stuff that they choose to research. So for sure, when I was preparing to do this with CC12, I did not expect to receive a lesson about machine learning that factors in geography, art, politics, and measures of raccooniness. So very nice job putting that together, Chip and Izan. Wonderful talk. Okay, so next, as I mentioned a little bit prematurely before, so sorry about that, we have Yuya and Polly, and they are basically going to tell us everything we need to know to get started with iOS development. So everyone in the audience, let's give it up for Yuya and Polly. Yay! You might notice that we're taking a little bit of extra time to sanitize all of the equipment between presenters. So sorry for the occasional sounds. Okay.
Ready? All right, hello everyone. Thank you for coming to see us today. We're so excited to be able to actually talk to you guys at last. We've been practicing this for several long weeks now, so we're glad to actually do this in front of people. Today, so my name is Polly and this is my co-presenter today, Yuya. We'll be talking to you guys about what it's like to be an iOS developer. So we'll be going through what kind of software do we use to code, what kind of code do we actually write, and how do we upload our apps to the App Store. But first, let us introduce a little about ourselves. So, my name is Polly. I'm originally from the UK. I've been here so long now that I don't actually sound British anymore, so yeah, it pains my heart, but there you go. I've been working in game localization until now, and I started to code around half a year ago. I decided to do a career change. And yeah, just in my private life, I use a lot of Apple products, so I figured as part of my coding journey, I would love to try my hand at creating my own app. So that's why I'm here with Yuya today, but let's introduce Yuya.
All right, thank you, Polly, and hello everyone, my name is Yuya. And it's funny, we've been working on this project for about 5 or 6 weeks, but it's actually the first time we see each other. So yeah, I hope she didn't surprise how short I am. But yeah, anyway, talking about myself, I was working as a tour guide in one of the famous tourist spots in Japan called Asakusa until last March, and then wanted to start something new. So at the same time, I joined Chrysalis foundation course. And then I started learning from JavaScript, HTML, and CSS. But yeah, like now I'm interested in making an iOS app. So finally, Polly and I decided to work on together for this project. Okay, so today we are mostly going to cover what Xcode Swift is, and also how to publish your app onto the App Store. So like by the end of this presentation, you will know like the basics of like what it's like to be an iOS developer. And also for the learning purposes, we also built the our baby app, which is called Chance Brain. So we would like to demo that for you first.
All right, let me just set that up for you guys. Oops, sorry. Okay, so I'm currently streaming this from my phone right now, so if we just open up the app, it's a Weber app, so in the background what the code is doing right now is it's just contacting the Weber API to get the information for the location where we currently are, and that will show up, and there you go, Mitaku is currently 27 degrees. Apparently it's thundery outside. I actually think it's actually sunny outside, but this is something you get with Japanese rainy season. The weather always comes back as thunderstorm. Let's check out what is it like in London. It's 10 degrees, that's actually sunny, a bit chilly over there though, it's not very warm at the moment. Let's check out Paris. And it's a little bit warmer, but still pretty chilly, but there you go, that's a demo of our app.
All right, thank you for the beautiful demo, Polly. So yeah, I heard like today it's gonna rain in Tokyo, so, and also please be careful if you live in Mita, like stay safe from the lightning struck. But yeah, anyway, I want to describe like what kind of process we took for making this app. So first of all, we talked about what type of apps we want to create, and then some of the examples were like Instagram clone app, group journal app, and obviously the weather app. And after that, like we talked about what type of features we want to add for our app. And then finally we decided we decided to making a weather app. So some of the features were a user can type the location or select the location by GPS, and then check the weather, and then whether he or she needs to bring an umbrella, something like that. And then we started coding. So once you have an idea of the app, the question you might want to ask next is, how do we actually start writing our code? So if you want to make an iOS app, Xcode is going to be your best friend. It's made by Apple, so you can make an app for Apple devices, and also it comes with built-in interface builder, which allow us to create beautiful graphical user interfaces. And also, since it's made by Apple, it might not be too surprising to hear that it's only available for Macs. So sorry for Windows users. But if you want to try Xcode, you need to get hold of a Mac from somewhere else. And also, I actually have a good news. For those of you who have never tried using Xcode or using Windows or other laptops, Polly is going to show what Xcode looks like.
Yes, thank you, Yuya. Okay, before we dive into it, I'm going to show it to you on my computer, but before that, I'd just like to take a minute to explain what you're going to see on screen, because Xcode gives you a lot of information, so it can be quite overwhelming to start off with. So let's just go through that first. So this is a screenshot that we took from whilst we were working on our project. Immediately you can see there's just so much on the screen, you're just like, what is going on here? So let's just break it down. First of all, on the left-hand side, we have our project tree. So this is all the files that we have in our project right now. In the middle, we have, this is called the interface builder, which Yuya briefly mentioned, and I'll talk a little bit about this more in depth in a second. Basically, this is where we can see exactly what is going to show up on our app. To the right-hand side, this is the utility area. So any options that you have related to anything that's on screen, buttons or background or whatever, you can choose the color, the font size, anything that will be on this side. And finally, the debug area. So any errors that come up whilst you're using the app or anything that you print to the console, this will show up at the bottom. So this is just a general overview of how the screen is set up. So let's actually take a look at it. So it looks exactly what you just saw. But this section in the center is the interface builder. So this is all the code to do with what you can see on screen right now. And one of the really cool things about Xcode is that it actually provides you with a drag and drop library that you can use to put things on screen. So this is really nice. It's so easy to kind of do things. So let me show you what I mean. You probably can't see my cursor too well, but right now I'm up in the upper right-hand side. So if I just click on this plus button here, you can see we have a list of all the things that we can add onto our app. So I just choose a button here, I just drag it onto the screen, and as simple as that, we have our button. Just make it a little bit bigger. But yeah, once you have the element on screen, you can manipulate it however you like with these options on the right-hand side. So for example, let's change the background color to orange. And there you go, we have, as simple as that, we have this giant, ugly orange button on our app, and it's really cool because having come from trying to do HTML and CSS and all that stuff with JavaScript, and manipulating the DOM and stuff, this is the easiest thing ever. A child could do this, so that was really nice. But let's get rid of that because it's ugly. But yeah, a really nice thing about Xcode as well is that because it's by Apple for Apple products, you kind of have access to all of that shared knowledge of, Apple design and stuff like that. So for example, if I come down here to device, if I click on here, I can actually, there's a list of different device sizes that you can test out your app. So for example, let's go down to iPhone 4S. If you want to see what those users are seeing, you can just click on that and immediately you can see what does the app look like for users of different sizes of device. So this is really cool. It allows you to check, make sure that everyone's seeing the same sort of thing and that nobody's having any graphical issues. So that's really cool. Lastly, one really nice thing about Xcode is that Apple actually included all of their official documentation within Xcode. So, for example, say you have this code that you wrote months and months ago and you're not quite sure, you can't remember what's going on. You didn't write enough comments, which is a very common thing to do. But say I've written this function here, like text field did end in editing, and I'm thinking, where did I, what's this going on here? If I press Option on my keyboard and then click on the function, Apple will give us some information about it. So you can see I have a pop-up here, and this is basically describing like where the function was first declared, what parameters it takes, and some information about it. This also works for like elements that are built into Swift. So for example, maybe I'm thinking, what's this UI text field? Do the same, press Option, and then click on it. And this is like actually this is a summary from Apple's official documentation. So instead of kind of jumping out of the screen that I'm in and going to like NPN or Googling, like, whatever, what is this thing? I can see it right there in the screen. So this is really nice. Like it kind of helps you not to sort of get out of the zone and when you have to go and Google other things on other screens, so that's really cool. But yeah, that's a quick overview of Xcode.
Alright, thank you, Polly. And now you guys know how to use an Xcode or how to make a beautiful orange button. And talking about the design, I want to cover another thing, which is an up icon. And this is something we created for this project, like navy background and simple umbrella shape. So like at this point, I want to cover like how we made this icon and also some tips we can provide for you. So in order to make an up icon, you need to have some sort of graphic design tools. And we use Adobe Illustrator for making our up icon. But for those of you who do not have like a graphic design tool on your local machine, I would recommend using Canva. And if you go to this website, you can easily create your app icon for free. And also, you can see like you can also create a business card, presentation slides, and also, especially for now, like you can make the virtual background for Zoom meeting. And I've been using Canva for about half a year, and I really like this because it's really easy to use and then simple design. So I can definitely recommend using this website if you want to. And also another tip is you have to provide different sized icons if you want to upload your app onto the App Store. So for example, if you open your iPhone, you will see app icon on your home screen, but also like some other places like notifications or App Store settings, like pretty much anywhere with different size like that. But no one wants to make them manually. So I can also recommend another website, which is an app icon generator. So if you go this, and then by simply drag and drop your 1024 by 1024 image to here, those different size icons are auto-generated. So all you need to do is just grab the file and then drop in to your Xcode project, and ta-da, you will get different sized icons. Alright, so now you know how to use Xcode and how to make a beautiful app icon. So let's talk about the Swift programming language. So before I hand it over to Polly, I want to describe a little bit about Swift. And it was released in like 2014 by Apple. And I wanted to take a look at this survey result from Stack Overflow. And actually, Swift was the #6 most loved programming language last year. But the thing is, yesterday, one of our friends sent us a link for the developer survey 2020. And Swift dropped down to #9 most loved programming language. But yeah, that's about Swift, and I can hand it over to Polly now.
Thank you. Yeah. Yes, it might have dropped down a few places compared to last year, but actually we really enjoyed our experience working with Swift. Coming from a JavaScript background, Swift was quite a different experience for us, and let us tell you why. Well, the biggest challenge for us was the fact that JavaScript is loosely typed, and Swift is strongly typed, so this was something that we've never come across so far. What does this mean? Let's take a look at some code to show the difference. So in order to declare a variable in JavaScript, we might say something like let greeting equals hello. It's pretty obvious what's going on here. We're just making a variable and then storing the string hello in the variable. Really simple, really easy. To do the same thing in Swift, you might say something like let greeting string equals hello. And you can see here straight away, we're explicitly saying, okay, greeting is going to hold string data only. Once we've declared it to hold string data, we cannot then say we can't store any numbers in here, we can't store any booleans in here. This variable greeting will only hold string data and string data only for the rest of its life. So yeah, this kind of inflexibility of Swift was a new thing that we hadn't come across so far in JavaScript. We got a lot of errors when we were doing our coding just because we had the wrong type of data in our variable. Yeah, Xcode will give you like errors like straight away. It's like, hey, you got error. I know, but
It was a nightmare.
yeah, we had a lot of errors there. But this also rolls over into functions as well. Like, I was kind of surprised to see how we write functions in Swift. This is an example of a function from our code, but here we're just getting the Weber information here. So we have fetch Weber brackets city name string. So sorry, this mic is broken. Anyway, so no, it's fine. Sorry, where was I? So in order to, when we declare the function, we have to say explicitly what the parameter name is. So here is city name, and explicitly that we're going to store string data. I'm just going to put this down. Like, there's no point in holding it. That we're going to store string data in the parameter. So like this is really, it's really clear. It's really obvious what's going on. When we call the function, again, we also have to say like what is the parameter name, and then we pass in the information. So this is like really rigid for me, coming from a JavaScript background. Like you don't have to ever declare what the name of it is. Like you do put the name, but like you don't have to repeat yourself here. So it felt quite rigid. It felt quite strict. So this was, yeah, it was just kind of a new way of thinking about how we're dealing with our data and just being very careful with what types of data we have. But yeah, I think the rise of obviously like TypeScript and all these other strongly typed languages shows that this is probably the way forward of where programming is moving towards, because it helps you to get rid of all your errors at an earlier stage than JavaScript, which lets you just run all with your errors and it will just, you know, crash your program later on. But yeah, I don't know, how did you feel with Yuya?
So yeah, for me, I think for both of us, but as Molly mentioned, like we came from like JavaScript background, like we have like code, like we wrote down a lot of codes for JavaScript, so it was kind of hard to get used to the Swift syntax at first. But like once you get used to it, like it's not that difficult. But I still need a time to figure it out, so I would love to learn it more. Yeah. Is your mic working?
I think so.
Cool.
Yeah.
Okay. All right. So, and by now, you already know like how to make your app, like how to build your app. So let's talk about how to upload your app to the App Store. All right. So in order to upload to App Store, you have to submit your app to Apple first, and then they will review your app. And if your app is approved, yeah, you will see your app on the App Store like within like a few days. However, if your app is rejected, you will get an email from them. But yeah, like with which part should be fixed, so like you can try it again. So that's about that's the like basics you should know. And also, so submitting your app to Apple is not that difficult because like you only need to do like two things. The first one is you are going to, sorry. Yeah, it's okay. But yeah, like you first of all, you need to sign up for the Apple's developer program, and also after that,
Sorry.
it's okay. After that, you're gonna fill the information of your app on the App Store Connect. So yeah, let's take a look at Apple's developer program first. So in order to sign up, you need to pay $99 per year. But once you signed up, you can get lots of benefits. And one thing I like is you can get the analytics of your app once you upload your app to the App Store. So yeah, like you can gain the insights, you can see the app performance, which is I think really cool. And then after that, you're gonna fill the information of that. And some of the basic information are like the name of the app, the language, or something like that. And also at the same time, you have to provide this description of your app, or keyword or like screenshots. But those things are really important. You have to spend time on keyword research or app store optimization. And I'm going to explain why. So for example, if I go to App Store and then type task management on the search bar, the result shows up, which is like basically to-do apps, but pretty much like same functionality, and then like they're all like resemble. And then like the list kind of goes on. So if your app is invisible in the App Store, you won't get downloaded. Your app won't get downloaded. And also, if someone takes a look at your app on the App Store, you have to convince them that your app is worth downloading. So that's why you have to spend time for like keyword research, App Store optimization, in order to rank highly and then get more downloads. So yeah, that's about the information. And finally, you will submit your app with those information to Apple. And if your app is approved by Apple, you will see them on App Store, finally. Great. So hope your app is on the App Store and then gets lots of downloaded, and you will be famous, hopefully.
Yes, so to wrap it up, today we've told you guys about Xcode, about Swift, and about how to publish your app to the App Store and become rich and famous. Maybe. But yeah, thank you guys for listening. We had a ton of fun researching and making our app with this, even though we had so many problems with Swift. But yeah, hopefully you guys are inspired to make your own apps now, and thank you guys for listening.
Just scan it and contact us. Yeah, thank you so much.
Okay, thank you so much, Polly and Yuya. This was so good. I actually want them to come and perform it every time we do senior projects because a lot of our students tend to do mobile apps, and I think that that was a very thorough explanation about that process and what students should expect. Also, you may have noticed that up until this point, all of our tech talks have been done in pairs. This is something we did with CC12, and we're super excited about it, and I think that the last pair demonstrated just how much synergy you can get from presenting with another person. So awesome work, guys. And so finally, we have a revenge tech talk. So we're gonna welcome Sarah from CC11. She actually agreed to come in and do this whole new talk, despite having only graduated and having to go through this process just a few months ago. So really excited to have her here, and she's going to be talking about JavaScript animations with green socks. So let's give it up for Sarah.
Hi everyone. So yeah, like I mentioned, I'm here from CC11. I will be talking about JavaScript animation with the green sock animation platform, also known as GSAP, which is much easier to say. So I'll be calling it that for the next 20 minutes. So, so a little bit about me first. I am an Australian web developer. Like I just mentioned, I graduated back in March, and I enjoyed the tech talk process so much I just had to come back. My favorite languages are PHP and JavaScript, which is really great for the Chrysalis program. Right, so I'm going to be talking about GSAP. And I'm sure that the very first question that all of you guys are going to be asking is, Sarah, why should I be listening to you for the next 20 minutes? Why should I care about GSAP? These are actually two questions, I believe, can be broken down into, firstly, why is animation important? Why does animation matter if I'm designing a web page? And secondly, why should I care about GSAP over any other alternative technology? Because there's a lot of other ways that you can animate things in the browser these days. So I'm going to be spending about half of the talk, up until here, talking about these two questions, why GSAP is important, why you guys should be listening to me. Then the rest of the talk, I'm going to talk a little bit more about how to use GSAP and the technical portions of it. So, looking forward to that. Before I jump into this, I would like to set the stage, get everyone familiar with what GSAP is. So if we come over to the GreenSock website, you can find us at greensock.com. If you're watching from home, you can probably browse through this while I'm talking actually. Here GreenSock has a showcase which shows off a bunch of different samples of websites that are being made using GreenSock. I picked out one of my favorites, which is the Retro Economy. I believe this is also using 3JS or some other 3D library. But all of the tweening, all of the animation, all of these special effects, that's all GSAP. That's all the magic of GSAP. I'm not going to be talking about anything this complex today, but hopefully I'll be able to give you guys a quick introduction to this, get you guys interested, hopefully, in adding some magic to your next project. Alright, so let's come back to these two questions. I'm going to take a step back and talk a little bit about why I think animation is important. So I have picked out 3 reasons that I think animation is important, but I'm sure that everyone in the audience today has their own reasons. My first reason is, firstly, user retention. So in 2014, I believe, Time magazine published an article discussing how users spend an average of less than 15 seconds on each web page before moving on. So animation is a great tool you can use to catch their attention, maybe convince them to stay more than 15 seconds on your website, and maybe convert them into regular customers. Second reason is usability and understandability. So something that you might notice about these slides is that these are also animated. This is all animated using GSAP. So animation is just a great way to draw users' attention to what you want them to be looking at, makes your content more digestible, easier to consume. It's a lot easier to understand. Right, and the last reason I'd like to talk about is just because it's cool. I think a lot of us get into development because we love making things. Animation is really one of those things that's really satisfying to look at the end of the day when you have a finished product. Right, so those are my 3 reasons. You can feel free to share your own reasons with me later. Next, I want to talk a little bit about GSAP compared with other technologies you can use for animation. So, lots of different modern JavaScript libraries you can use today that I'm not going to be talking about today. Today I'm going to be talking about CSS and jQuery. And you might be wondering, Sarah, why are you talking about these two? And my reason is because these are 2 pretty common technologies still being used today. If you are still using these, if you get stuck using these for animation in a future job, I'd like to maybe have a go at convincing you to pick up maybe an alternative if you want to use animation in the future. So a quick introduction to this firstly. So CSS, if you have touched web development before, chances are you're already familiar with this. So hands up, how many people in the audience have worked with CSS before? Yeah, that's basically everyone. For anyone watching at home, basically everyone put their hands up, which is what you would expect. Out of curiosity, how many people have used CSS animations and transitions? Yeah, a few. Less, but you guys can hopefully help me out with some questions later. So, for people who aren't familiar with CSS, it is a styling language. It is used basically universally to make websites pretty, and it does happen to have some animation features. Next, jQuery. Now this is a little bit less prevalent these days. When I was deciding whether or not to include jQuery in this talk, I actually wasn't sure because I was thinking, who really uses jQuery these days? It's kind of being pushed out of the limelight by the hip new kids on the block, like React, Vue, Angular. But I looked this up, right? I looked up the numbers. According to builtwith.com, out of the top 1 million websites online today, in terms of traffic, over 80% of them are still using jQuery. Out of the top 10 million, over 75%. So, statistically speaking, chances are you're going to end up using jQuery sometime in the future, and it's still worth talking about. So out of interest, how many people have used jQuery before? Yeah, how many people have done animation of jQuery before? So, yeah. A few people, so it looks like you have fun, Felix. Alright, so today I'm going to be talking about pros and cons of each of these. So let's start off with a pro of CSS. So this is native. If you care about file size, I think the number of people who care about file size these days is decreasing, but if you care about that, this is a pro, so you don't have to download anything, your users don't have to download anything, everything's built into the browser. big relevant important benefit is that it is very common, right? Because it's native, it's basically universally used. Chances are you already know CSS, as we just saw. Chances are your coworkers and your future coworkers already know CSS. So there's no possible learning curve. If you just want to add some transitions in, it's pretty easy. Another pro of CSS is that it's very fast. But I do want to discuss this a little bit more in detail later. And a con of CSS is that unfortunately it is a little bit inflexible. It lacks a little bit of functionality when it comes to animation at least. So this is something that you'll find in common with CSS and jQuery. Because these are not dedicated animation solutions, jQuery as well is supposed to be used for DOM manipulation and DOM traversal primarily. You will find it missing some features that you would usually want out of an animation solution, right? You find yourself fighting it a little bit when you should be working together with it. So I will be showing on the next slide a sample of code snippets in each of these three tools so we can compare how easy they are to use, but we'll get to that in a moment. So I want to first talk about some pros of jQuery. So a pro of jQuery is it is jQuery. Like I mentioned before, it is still the most commonly used JavaScript library online today. Because it's so widely used, there's a lot of support, a lot of documentation. Chances are, if you want to do anything with jQuery, there is a Stack Overflow question and answer just for you. Chances are, if you don't want to do something with jQuery, if you just want to use vanilla JavaScript, there's still a Stack Overflow answer that says, why don't you just use jQuery? So it is a little bit frustratingly common. A con of jQuery is that it is jQuery, unfortunately. It is, amongst other things, it's pretty bloated. If you're not already using it for your projects, there's not really much point using it just for animations. It is very slow. jQuery is so slow that it gave the entirety of JavaScript animation a bad name, right? If you're under the impression, if you're in the audience right now, and you're under the impression that JavaScript animation is unacceptably slow compared to CSS animations, and that's why you're still using CSS transitions, that's a lie. That is jQuery's fault. Most other JavaScript libraries will not run into the same issues, which actually brings me really neatly to my first pro for DSAP, which is that it's fast, right? DSAP is about 20 times faster than jQuery, and in certain use cases is actually faster than CSS. So if one of your misgivings about JavaScript animation was performance, and that's why you're still stuck on CSS animations, maybe this is a good time to start looking into some JavaScript solutions. If you don't believe me, you don't have to. If you come over to the GreenSock website, so again, this is greensock.com, they actually have a speed test here. And it shows, it just animates a bunch of elements really quickly, and it compares the performance of jQuery with a bunch of other JavaScript libraries and with CSS transitions. So if you're feeling skeptical, feel free to check that out. Yeah, it's very interesting stuff. Okay, so back here, I'm going to talk a little bit more about the pros of DSAP. It is pleasant and easy to work with, which is something great to hear if you have been stuck working with CSS transitions and jQuery up until now. So DSAP is an example of a solution that's actually built to make life easy for animators. So yeah, really easy to work with. And also it's packed full of functionality, it's super flexible, it can tween basically anything that JavaScript can see. And yeah, it's also got a bunch of plugins if you want to do anything extra. And lastly, before I move on to examples, I should talk at least about one con for DSAP, which is that it is a third-party library. Unfortunately, this does mean if you want certain features or if you want to use it in certain commercial environments, you do have to pay for a commercial license. So if your budget is tight, that's something to keep in mind. Okay, so I've been promising for a while that I'm going to look at an example. So we're going to look at an example. Here we have a scene with a bouncing ball. There are actually two animations being applied to this ball right now. Can anyone in the audience tell me what the two animations are? Possibly. Yeah?
Translate?
Translate, yeah, that's
it?
yeah, that's a translate, yeah, two translate animations, yeah?
Translate Y, translate X.
Yeah, exactly. Yeah, Vic got it. So, I can't give out prizes, but maybe you can get a free shirt from Chrysalis. So, if you didn't hear that, what Vic just said is there is a vertical animation, which is the bouncing up and down, and there's a horizontal animation, which is the bow going from side to side. So let's have a look at how each of these three tools, hand tools, attaching two animations to this bow. So first is CSS. Don't worry if you can't read this or if you can't be bothered. I just want to show you guys how much work is going into making this bow move. So here CSS actually isn't that bad, right? It's got three code blocks. One code block for the left-right movement, one code block for the up-down movement, and one code block here at the top, which attaches the two movements to this bow. It's actually not that much work, but I don't know if everyone necessarily would find styling blocks intuitive way to define animation. Maybe not, depends on you. Next, let's have a look at jQuery, Felix's favorite jQuery. So here we have, you see there's a bit of a chunky boy here. We have 2 blocks of code here. This again have 1 block of code for the up-down animation and 1 block of code for the left-right animation. And this is an example of what I was talking about before, where because jQuery wasn't designed with animation in mind, you kind of had to fight it for some features that you would usually expect to be inbuilt. In this example, jQuery does not actually support infinitely looping animations. It doesn't support reversing or yo-yoing animations, so you have to kind of build it yourself. It is a little bit frustrating, and it can be really difficult to do when you get to more complex animations. So let's have a look at how GSAP handles this instead. So we have 2 lines of code for 2 animations, which is, I think this is pretty easy. Anyone who's nitpicky in the audience might argue that this is actually 2 code blocks because you can add line breaks in, but the point is that all of the features that you would expect an animation toolset to have is here. All you have to do is add in the configurations that you want. So I am hoping that I've made a good case for GSAP because the rest of this talk from here onwards is going to be entirely about how to use GSAP and how to think with GSAP. Okay, it's been a while since I taught this one, so let's take a breath. Okay, diving into the rest of the talk, before I get into any code, I want to talk about a concept called tweening. You might be asking, Sarah, why are you stopping to talk about tweens right now? Well, I have heard GSAP described before as a tweening library rather than an animation library. And I think that's pretty accurate. All of the animations in GSAP can be described in terms of tweens. So, what is a tween? Tweening is an animation term. It comes from the word in-betweening, right? And the idea of a tween is, let's say you have an object at point A over here. So this is the beginning of your animation. And you have a point to point B over here, which is where you want the object to end at the end of the animation, right? So point A and point B. Tweening is the process of calculating all of the frames in between to make a smooth transition, right? From A to B. So in case that isn't clear, I have an example here. So we have this bow. This is at 0 pixels on the x-axis. Let's say that we want to bring this ball over to our point B. So we want this ball at point A to move 100 pixels to the right to point B. So what GSAP does is you tell GSAP point A and point B, and GSAP will calculate all of the values, all of the frames in between to make a smooth transition. So you see, in this case, it's pretty trivial because you might say, well, to get to 0 to 100, all you have to do is do 1, 2, 3, 4, 5 all the way up. And I would say, yeah, it's pretty simple. And all of the animations in GSAP are based on this super simple concept. So now that we know that, just keep that in mind moving forward because I will be mentioning tweens a few more times. Let's look at some code finally. So here we have exactly the same animation as we just saw on the previous slide. We have a bow and it's moving across the screen 100 pixels to the right. And above the animation, we see the line of code responsible for running it. I have here broken down this line of code into 3 parts, and we're going to drill into each of these parts and see what's going on. So in red here, we have the method name. In yellow, we have the target. And in green, we have the values. So I think that the values are the easiest part to explain. So I'm going to start with this green section here. So in green, this is what you give GSAP when you're telling it the point B. You're telling GSAP where you want the animation to end. In this case, you're saying, hey GSAP, can you take this ball, and at the end of this animation, I want it to have an X value of 100. And it takes care of all the tweening for you. As you've probably guessed, GSAP can animate a lot of other things aside from positions, so I've got some other examples. So in this case, we're telling GSAP, hey, change the color to red. In this case, we're telling GSAP, change the opacity to 0, and GSAP makes it fade out of existence. The third example is a little bit more special. We're tweening two properties at the same time. So you're just saying, GSAP, I want, at the end of this animation, this ball should be at x equals 100, and it should be scaled up by 3 times. So it should be 3 times bigger. So GSAP has no problem with that. You can animate, you can tween as many things as you like with GSAP. Sky's the limit. So I kind of mentioned this a little bit before, but GSAP can tween anything that JavaScript can see. So that includes JavaScript variables. That blew my mind when I first heard about it. GSAP can tween JavaScript variables. It can tween CSS properties. It can tween SVGs. Super flexible. It's super fun to play around with. Okay, let's move on backwards. Going to go back to the first parameter here, which is in yellow. This is the target. This is where you tell GSAP what object you want it to animate. So in this case, as everyone in the audience is familiar with CSS, you should be familiar with the CSS selector. So you can pass GSAP a string, which is the CSS selector, telling it all of the objects that you want it to animate. You can tell it as many objects to animate as you like. In the second example, you're passing it a JavaScript variable reference to a DOM element. So this is actually pretty fun because GSAP interfaces really well with third-party libraries. For example, if you're using Vue, you can also pass it a Vue reference. If you're using jQuery, you can pass it a jQuery object. It's super flexible. And very last thing here, I'm going to move on to the method name in red. And this is, GSAP has a bunch of different methods, but today I'm talking about 3 of them, which are to, from, and from to. So the difference between to and from, you can see just looking at the examples here. In to, you are telling GSAP the destination of the animation. You're telling GSAP point B. With from, you're telling GSAP the origin of the animation. So you're telling it point A. So in this first example, it starts off in the middle, moves off to the right. In the second example, it starts off on the right and then moves back to the middle. And you can probably guess from the method name that the third example, from to, you tell GSAP both point A and point B, and GSAP will take the object over from point A to point B. So, hopefully that's been fairly straightforward. These are like the bare basics of GSAP. It's super flexible. There's a ton of other stuff that you can do with it. I'm just going to speed through some other examples. So in this green section here, you can also bring in some special options. If you want to change the speed of the animation, you can change the duration. If you want to make the GSAP wait for a little bit before playing your animation, you can set a delay and it will wait a few seconds before playing. If you want to give it an ease, so this changes how the animation gets from point A to point B. You can say it should be elastic or it should be bouncy, and it'll spring a little bit at the end. This is what really makes GSAP great as a tool. It's thinking about what animators want, and it makes life easy for you. So I'm just about out of time for today. So what I'm going to do is I'm going to throw my contact information up on the screen. So I'm Sarah Dating on Twitter, GitHub, and LinkedIn. Hopefully if anyone in the audience has been inspired by me to pick up GSAP, or even if you have used GSAP in the past and you want to show off to me, please feel free to hit me up. I would love to see what you make. And the QR code on the screen just goes to the source code for these slides. So thank you all very much for your time today.
Okay, thank you so much, Sarah, for that wonderful and energetic presentation. It's been like a huge pleasure to have you come back and do that. So while I was watching that and watching everyone's presentations today, so pardon me, I have to bend down to plug this in here. The thing we tell our students never to do. Okay, and so what I was thinking about when I was watching everyone's presentations, and all of you who are watching online, you can't see the assortment of people that are here today. But we've got Sarah, who is from CC11, to come back to do another talk. And we have Rafa here, who is our engineer in residence from CC11. We have staff, right, who graduated from CC5, and people from CC10 who are now joining us as staff as well. We've got so many supportive members from CC12, and then we also, of course, thank you, Connie, we have a wonderful, wonderful member of CCJ1, our first ever Japanese immersive cohort. So while I was thinking about this, something that struck me very, very, very strongly, and you guys will have to give me just a second. Let's see here. Okay. So, something that struck me very, very strongly, and I was hoping to show you, but I won't take up too much more of your time, is that Code Chrysalis has built this amazing community, right? We're all here, we've all experienced really, really hard times recently, and this cohort in particular, and the Japanese immersive cohort now too, are really, really working in just super unknown and special conditions. And so our CEO likes to say, don't just survive, but thrive. And I think that we are able to do that together, right, in this Code Chrysalis community that we've built. And so thinking about the community, I thought, well, a lot of you have come to us from our Foundations program. This is the very first intro to code for many of you who have decided to join us as immersive students and as staff and as friends and family members, really. And so I wanted to take just a couple of moments to let all of you watching know that we know it's hard times, and we want to help you improve your skills, and we want you to come together with us and be a part of our community so that Code Chrysalis can continue to do this for the foreseeable future. And so we have something that we are introducing and rolling out called Foundations Lite, which is if you're not sure if you can commit to a 5-week, sort of rigorous program, let alone a 12-week full stack immersive program, you can have access to our Foundations curriculum and sort of study at your own pace. And so we've rolled out that as a new program. We also have our Foundations program and our Japanese Foundations program that are carrying on as usual, a mixture of remote and on-site courses for those, I believe, as well. And so we have all of these, and during this time we're offering it as a 15% discount. So if you would like to take this program, now is a really, really good time to do it because you can save a little bit of cash with us. So that applies to people who have registered and paid before the end of August, so please check that out. I really appreciate that. And yeah, how you would get access to that discount is just by mentioning that you were here and you heard us talk about it. So thank you very much for listening to that part. I really think that this community is the strongest thing that we have built beyond, of course, like turning out fantastic engineers. And so I want to invite everyone to a couple of events coming up. The first is CC12's Demo Day. They are actually going to start their senior projects from next week, and I'm sure feeling a little bit anxious about that. But it's very, very exciting. So that's going to be Thursday, June 25th in the evening, and that will be available to be watched online as well. And then if you enjoyed these talks, I see Show there in the back, CCJ1 actually has their Big MiniConf coming up shortly after CC12's Demo Day, so that's going to be Saturday, June 27th. So please tune in for that. It's super, super exciting, and they are the pioneer class. I hear gasping in the back. But as those of you who have just finished this, and all of you watching, if you're in the graduate community, it feels that way, and then you do it, and then it feels great. So we're really, really excited to see those things. So yeah, without taking up too much more time, thank you so much. Congratulations, CC12, for finishing your Big MiniConf. That was awesome. Yes! Thank you so much for coming back. I really, really appreciated that. That was awesome. Okay, so everyone have a lovely Saturday, and see you again in a few weeks. Bye!